Hey, so looking at the calendar, I don't know. We're on the 16th. I haven't put anything on there, but I do have. I'm gonna do a little bit of 3-2 notes just to kind of. Oh, I don't want to say enable you for those that didn't watch that Ed puzzle. I'm not even gonna look. I just it upsets me when I get a lot of people that don't do what's going on, don't know what's going on at home, as far as not doing stuff, but use your time wisely. You got a lot of time, more than ever, to do that. In our shortened schedules. I mean, today we have an eighth hour. We've had that since the beginning of the year. What's eighth hour? But I'm going to go ahead and do a couple. Even if you looked at the video, some of these are a little tricky. All right, so I do want to cover those for you. For those that did watch the video, that'll help you out. And then we're going to do a quiz, which is not 3-2. It's all the other stuff. And I'm going to be honest, we're like done. I don't know what to do Friday other than more review and maybe throw one more review assignment out there. And I guess I could put that on today, but I'll put it in that calendar, because I got nothing new. When we come back on the 22nd, we're going to start chapter 4, which helps and does review some chapter 3 stuff. And then we're planning on the test being the 25th or 26th, on this chapter. So I don't know. We're stretching it out. Again, those that are falling behind like all year long, this is a chapter where you have a lot of more extra time to get some of this stuff done and really focus on what we're doing here today, to get that done. But I don't know what else to say. Um, Lead a horse to water, but you can't make him drink, is a common statement that people make about that kind of stuff. Alrighty, so here's 3-2. And then again, this kind of enables the ones that didn't watch the video that were supposed to. But it also helps those with these cryptic, different type of questions. Up at the top here, before we get into those, I will do the highlights and synthesize the chapter, or the section. So again, this section has non-trig in it. Because we opened up the world of radians opened up a world of these new formulas, or formulas that you already know, but we can rewrite them. So one of them is arc length. And those that watch the video, which are supposed to, I'm going to keep laying it on thick. I don't care. So frustrating. All right. Arc length is related to circumference. Circumference is just walking around a circle. How far did you walk? Like a circular path. How far did you walk? It's not area. And circumference is 2 pi r, which those that watch the video, I made that comparison. But then when we get radians, then we can have a more direct formula, because theta, as long as it's in radians, and that's a must. This must be in radians for this formula to be true. Then, oh no, I'm not. I did it again. Oh my gosh. Don't I do every time with 6 hour? Because I'm presenting in fifth, and then I think I'm presenting the rest of the day. Good. Show that on YouTube. Yeah, this teacher doesn't know what he's doing. I knew it. All right. So sorry. Thanks for telling me. Much appreciated. And Mike, you're always like the savior. I feel like you always, and some other people have, but Mike for the most part. So arc length must be in radians. So there you go. All I have is this little red up here. So blabber long enough, you're not really having to take much down. Okay, and you watched the video, or if you did, I show the comparisons between that and your circumference formula that and I'll probably blabber about it here later. And then the other is area of a circle, which I put in the video you were supposed to watch. Stop saying that, Mr. Samuels. No. All right. Tired of it. Okay. Area equals, how's that for the video? 1/2. Okay, so area is pi r squared. Okay, so where does this 1/2 come from? Okay, and it's r squared theta. So this is area wrong. I hope I didn't put that. I think I might have. Oh no. I was saying sector, but I hope I put sector in the other. Let's check. Let's see if I screwed up all of fifth hour. All right. Oh, thank the maker. If there is one in a public school, it says sector. Woo. Okay. All right. So area of a sector. I've been discombobulated all day, man. My computer just like punching me in the gut as I got into school, and it's hard to teach after all those things happen. That's my excuse. I'm sticking to it. But this is in radians. I should put this in the chat, but I can't see the chat because that's also screwed up right now. What is a full circle in radians? And the answer is 2 pi. And everyone should have said that. Remember that question, by the way. 2 pi times a half is pi. Pi r squared is the full area of a circle. So anything less than 2 pi, put in that position, you have less than a full area. You have an area of a sector, area of a piece of pi. So that's what that's all about. Oh, these have to be in radians. So another thing to remember, if you're given a question not in radians, you must turn it into radians. So again, radians to degrees. Actually, I should have went the opposite because that's where you really have to work with this. So turning radians to degrees, that's when you multiply by 180 over pi. Really, what you're going to have to do is if they give you an angle measure in degrees, you must convert it to radians before you use these formulas. And that's pi over 180. So this is the main idea of this section. These are the things that you had to work with. No trig, it's just area and arc length. And then they did do a tougher question with gears. I'm not covering that. You watch that video, and if you don't, if there's a gear question on the test, well, good luck. All right, got to be that way. We got to get moving, man. Some of us got to just get out of our ruts and move on. Finish off the year. We're almost in March. I can't believe it. I know it's like February 17th, but it's gonna go quick, man. Then we got spring break, and then it's gonna be almost May. Well, we'll see. But okay, so here's for those that did watch the video. The homework was number 1 and then 5. So 1 was pretty standard, but then 5, whoa, what is this? Okay, so find the radius of the circle. Okay, so I got to find this r. It's missing. Some people say it's right here. I found it. Math is easy. Anyway, find the number. Okay, and by the way, this should have labels on it, and I'm kind of sad that they don't. So I'm going to insert some. So I could see a student going, wait a minute, what's going on? Okay, I think I know this is theta, but what is this? And that's probably what they're not real good with. This is actually the arc length. So 14 pi, let's put inches on there because they should have a label, but they just expect you to put units when you maybe list answers. Okay, so all right, so I have arc length. So this is the formula I'm dealing with. The first one that I wrote. Okay. Oh, and that is the arc length. I could type 14 pi and press enter, and I would get 14, 28, 38, 42, probably like 45 inches. I'm just guessing what 3.14 times 14 is. And that's a numerical value. That's an ant walking around circularly their distance. So I can put 14 pi right here. I don't know what r is. And this angle is in radians. So I'm able to insert it as is, and I got no problems. If this angle was in degrees, you would have to convert it in this position by multiplying it by pi over 180. So that's the only big deal about this section. Really is nothing. Now, you know what, though? I got this ready for solving. I'm going to multiply both sides by the reciprocal. So that means I multiply this side by 4. Well, how nice is that? 7 pi goes into 14 pi. 7 goes into 14 twice. The radius is 8. And I put this in inches, so I'm going to make this. But since I put it in inches, the radius is in inches. So it's just using this formula, and you're just inserting the parts that you have and solve for the unknown. Really isn't a big deal. Okay, I just wanted to make sure you knew what to do there. And then this is the definition of a radian. Okay. Uh-oh, I need a phone call. It's probably a potential spam. Oh no. This is Lexi Samulus. I bet she missed class. Hold on. I knew it. Sorry, I got to do this during my kids are at home and we got to take care of this stuff. Lexi Samulus again. We're having problems with the 11-year-old. She's missing school. She wakes up, does a class, then she lays back down and falls asleep. Oh, so I got to text mom real quick. This is great. I don't care. We have the time for this. This is going to happen. We're doing it. Oh, we need to be back at school. Okay. Tired of this. Okay. Let's begin. Hey, anyone get an answer? S equals R theta. Lexi's in trouble. Okay. All right. So this is R. Really, what they should have is let's put miles. Let's make this a really big circle. There's big circles out in the world. And then this is 6 miles as an arc length. This is the definition of a radian. The definition of a radian is you take the arc length divided by the radius, and then that's how many angular displacement radians there are in that angle measure. So I put 6 miles here, and I'm going to put the labels in there for dimensional analysis purposes, and then 4 miles here. Oop, did a little and then divide by the miles. And then in a dimensional analysis, these cancel as well. So what's the label? That's the magic of radians. When those labels cancel, that's where a radian comes from. That's why we're able to use radians in real world measurements, feet, miles, inches. Okay. And then if you remember, when I defined a radian, wrong. When that person with a minute and a half video defined it, 1 radian was about that far, 2 radian was about that far, 3 radians was about that far, and then this was 3.14 radians. Oh, yeah, okay, so this is 1.5 radians as an angular displacement. Okay, so just trying to compare that with some things that we've already talked about. Oh, okay, and then I just wanted to do this one to hammer down the point. I wanted one example where they gave you the angle measure in degrees. And don't tell me I went too fast on that last one. I had to make a darn phone call in order to see what my kid was doing during that. So you should have had all the time in the world to write that down. Big yawn there, Nasir. Big yawn. Getting that oxygen. Can't see some of you. I just love this look. You know what? I'm looking like that from now on. The majority of you look like that. See, top of your head. I get the top of your heads memorized. This is just fantastic. You're killing me, Smalls. You see that new sign? Got that for the holidays. Anyway. Okay. So the each arc intersects by central. So find the length of the arc. So it's just trying to make sure that this was an arc length question. Okay, fine. So S equals R theta. Gave you all the time in the world to write all that down. This is just a Mickey Mouse plug-in, but it's not. You can't just plug in 330. It's R, 12.4 feet, and then it's 330 times pi over 180. Okay, you must convert this to radians to use this formula. This formula, the angle must be in radians. And if it's not, you will get it wrong. And that's all I have to say. You know what? You can type on your calculator. I'm done. I'm moving on. By the way, 330, I can't see the chat, but 330 is actually synonymous with 11 pi over 6. So that would be 11 pi over 6 when you take 330 times pi over 180. Look at your unit circle. And then this one, so I assigned 43. And then I realized I'm looking at this and that is a little like, what's going on here? Obviously, I see I don't have the angle. So, okay. But it says find the area of the sector. What? Okay. I thought it was going to say find theta. Weird. Okay, I know I have the radius. Let's put this in. Let's say meters. Let's give the metric system some cred. So what is this thing? Is this the area? No, but it says find the area. Oh, so this must be the arc length. So again, if I was looking at this as a student, I would have been like, what is this 15 pi doing here? All right. And that's why I wanted to be here for you. And then that must be in meters as well. They expect units, but they if you looked at the answer at the back of the book, they'll probably say units squared for the final answer. I'm just inserting that because I just want some real world values. Okay, so all right, they tell me to find the area, which is this formula, and theta is in radians, but I don't have theta. I do have r, but I don't have the area, and that's what I'm supposed to find. Oh, okay. So I need to find theta from this given information. So I need the arc length formula because I have the arc length. And we're going to put meters there. And I do have the radius. Okay. And then look at this picture anyway. Watch what happens when I divide by 10 meters. The pi stays. And 15 over 10 is 3 over 2. Doesn't that look like 270 degrees as an angular displacement? And that is actually equivalent to 3 pi over 2. So now, I'm going to go ahead and calculate this because I don't have to pull out the calculator. I know I said 270 because I just know it looks like 270, but you must put 3 pi over 2 radians. All right, and then actually I should put meters in here. And then that's why it's meters squared. All right, that's, but area is always units squared. And when you multiply radians by a unit, it turns into that unit. It's because radians come from units. They are derived from, 2 inches as a radius, 2 inches as an arc length. 2 inches divided by 2 inches is 1 radian, right? When you take those arc length divided by radius. Definition. Wrong. I'm going to the answer. 10 squared is a hundo. A hundo times 3 is 3 hundo. That's 300 pi over 2 times 2, 4. And then that's meters squared because that's what meters would be. And if you want a decimal, you go ahead and turn that into a decimal by typing it on your calculator. All right. So that's what's going on with that one. Thought I'd help you with 43. Then one more. Find the measure in radians of each central angle. The number inside the sector is area. Okay, area. So that means out of my brain, I pull out this formula. So that's your job. That's what you got to figure out. Okay, it's area. So I got to write that down and figure out what I have and solve for what's not known. Tells me right in the wording that this is the area. And then I can see that this is R. I have everything I need to find theta, and theta will be in radians because you have units here. Units will cancel out, and then that gives you angular displacement. Anyway, 4 squared 16, half of 16 is 8. And actually, unit squared goes there as well. And then that's times theta. And then when I divide and the units divide, what's left over is a radian. And there you go. There's 1 radian. Going back to the minute and a half video, when he did this was approximately 1 radian. This was approximately 2. This was approximately 3. This was approximately, approximately, I should say, 3.14. That was how radians were drawn. So that does look like 1 radian if you look at that old video. Okay, done with that. I'm going to end this video. Oh, you saw Lexi she's getting in trouble. Okay, can't wait to the end of this. We're going to find out what's going on with her. It would be fine if it was her first time. That's like the 6th time that's happened. So the youngin is falling into some bad habits. We got to get those figured out. We need to get back to school. All right, there we go.